The periodic table.
Reasons for classification of elements. The goal of element classification is to study each element and the interrelationship between the elements in a systematic manner. Elements having similar properties are arranged together in vertical columns called groups. Modification in classification leading to the modern table. The table shows the chronological order of evolution of the periodic table. Early chemists tried to arrange chemicals based on their density and metallic and non-metallic nature. Dobereiner's triads consisted of elements arranged in threes, where the atomic weight of the second element is an average of that of the first and the third element. This classification applies for the alkali metals like sodium, potassium, calcium, etc., and the alkaline earth metals. Newland and Mendeleev both classified elements in the increasing order of atomic weights. The first and the eighth element in Newland's classification have similar properties. Today we follow Moseley's classification of elements based on the increasing order of atomic numbers. Dobereiner's triads. Here are some examples of Dobereiner's triads. You can see that the atomic weight of the middle elements, namely beryllium and strontium, is the average of the elements flanking them in the table. The Dobereiner's method of classification has two main defects. One is that, though iron, manganese, nickel, cobalt, zinc, and copper are similar elements, they couldn't be grouped into triads. Secondly, elements with dissimilar properties were grouped together. Newland's law of octaves. Newland's law of octaves states that when elements are arranged in the increasing order of their atomic mass, the eighth element resembles the first in physical and chemical properties, just like the eighth note on a musical scale resembles the first note. Lithium resembles sodium in properties. Nitrogen resembles phosphorus in properties. The defects of Newland's classification are listed here in the slide. Mendeleev's periodic table. Mendeleev arranged the 63 elements in increasing order of atomic masses. He arranged the elements in vertical columns called groups and horizontal rows called periods. There are 8 groups and 7 periods in the Mendeleev's periodic table. The elements in a group have similar properties. Demerits of Mendeleev's table. Mendeleev's periodic table addressed some of the defects of the Newland's classification. There were gaps left for undiscovered elements. There were quite a few defects as well. The modern periodic table. Alkali metals are placed in group 1A and have 1 electron free to react in their valence shell. Halogens are placed in group 7A.
Noble gases are placed in group 0.
Elements of group 2A are called alkaline earth metals. They have 2 unpaired electrons in their valence shell. Transition elements are placed in the middle of the table. The inner transition elements, or the lanthanides and actinides, are placed in 2 separate series at the bottom of the main body of the periodic table. General characteristics of groups. Number of electrons in the valence shell is the same in all elements that belong to a group. Valency, or the number of electrons available for bond formation of all members of a group, is the same. The number of shells around the nucleus increases by 1 on going down a group. Elements of a group possess similar properties. Metallic character increases down a group. Nitrogen and phosphorus are nonmetals. Arsenic and antimony have both metallic and nonmetallic properties and are metalloids, and bismuth is a pure metal. General characteristics of periods. Electrons present in the valence shell increase when on proceeding across a period, but the number of shells remains the same. Valency with respect to hydrogen increases from 1 to 4 and then falls from 4 to 1 across the period. Valency with respect to oxygen increases from 1 to 7. Properties of elements vary widely. Metallic character decreases gradually across a period and finally becomes non-metallic. Advantages of the long form of periodic table. The long form of the periodic table overcomes most of the disadvantages of the Mendeleev's classification. It accounts for isotope placement and the behavior of anomalous pairs of elements like potassium and argon. However, it does not explain the positioning of hydrogen and does not include the rare earth elements in the main body of the table.